Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your same topic or the same chapter, that is chapter number 7, linking. So till now we have covered 4 topics of this chapter in the last class, and in the last class I have started this chapter, and now I'm going to continue with your next topic. But prior to that, let's take a quick review what we have covered in the last class. So let's take a quick review. In the last class, we have discussed about the compiler, GCC, that is your compiler phase. What is linking? We have discussed with the help of book. Let me start. We started with the chapter linking, and we have covered these 4 topics, that is compiler drivers, static linking, object file, relocatable object file. We started with the linking. So linking is a process of or the method of combining or collecting. First of all, it collects the data, then it combines the various pieces of code, that is various parts of the code. Code means any programming language code, and data into a single file that can be loaded into the memory and executed. Means linking collects the data, combines the data, load to the memory, then in the memory or by the CPU it will be executed. That is your linking. So linking means collecting, combining various pieces of code and load it into the memory and then execute it. Linking is done in 2 ways, as we have studied in the last class, either in compile time or either in runtime. When linking is done at the load time, that is when the computer is running the program, that is before executing the program, before doing the operation of the program, it converts into binary language, that is known as linking at the compile time. Whereas when the source code is translated into the machine code at the load time, or at the run time, or at the execution time, that is known as the runtime linking or dynamic linking. So linking is done in 2 ways, or can be done in 2 ways, either in compile time or either in runtime. Linkers plays a very crucial role or important role in the software development we have studied, and we have also studied about the features of the linking, that is what are the features of linking, why we are using the linking. This is understanding or why we are getting the knowledge of the linking, as we are not hi-fi programmers, we are not writing any big or the large programs, but why? What is the need? So question arises, what is the need of knowing the linkers? So these are the answers, or this is the answer to the question, that is what is the need to knowing the linking. So these are the 4 points, 4 to 5 points that need to or that explains why we need to understand the linking. First point says understanding linkers will help you to build large program. Suppose you want to build a large program, so it is a linker. If you have knowledge of the linker, you are able to easily manage or build large programs. Then second point says understanding the linkers will help you to avoid dangerous programming errors. There are so many dangerous programming errors which can affect the programming. So it is a responsibility, or it is a linking capacity. If we have a knowledge of the linking, so we will remove or avoid the dangerous programming error which even hurt the system, even exploit the system, anything that can be done on the system. So it helps to avoid the dangerous programming errors. Next point says understanding the linkers will help you understand how language scoping rules are implemented. That is, if there is a knowledge of the linking, so it is better to gain the knowledge, or it is better to gain the knowledge of the rules of the and the regulations that are implemented with the linking. Next point says understanding the linking will help you understand other important system concepts. That is, if I have a knowledge of the linking, so I am able to understand the other concepts also, other parts of the system also. That is the main advantage, that understanding the linking also helps to understand the other system concepts. Next, it helps you to exploit, or understanding linking will help you to, or enable you to exploit the shared libraries. So linking will enable you to exploit the shared libraries. These are the features, or these are the benefits that why we need knowledge of the linking. And we have discussed all these in detail in the last class. Format, we have discussed about this. This is relocatable object file. This is a diagram of the relocatable object file. There is a ELF header that is available at the top, that is ELF header. Then at last there is a section header table, And in between the ELF header and the section header table, there are multiple fields, there are multiple blocks. That is the most important part. That includes the relocatable object file. One is .text, one is .ro data, one is .data, one is .bss, one is symbol table, that is syntab, one is rel text, then rel data, then debug, line, str tab. We studied all these in detail. That is what is .txt, what is debug, what is symbol table, what is data, what is BSS, with the help of book, with the help of slide also, or PDF also. This is, we have studied about this in the detail. This is the section header table, that is the ELF header. There is the sections, that is the optional section, section 1 till section N. This is the segment header table. This is a text section that includes the coding part. Then .ro section, that read-only data, that includes read-only data, jump table. .data section, that is used to initialize or that stores the initialized global variable. Then .bss sections. Then symbol table section. .rel text section. Then rel data section, debug section. And then at last we have studied what is a process. So this is the diagram of the process. So this is what we have covered in the last class. Now I'm starting with your new topic, that is today's topic. What is symbol, what is symbol table, and what is symbol resolution? These are the three topics of the today's class. So first of all, what is symbol? This point says, or this paragraph says, every relocatable object module, that is M, has a symbol table. Means if there is any relocatable object module, that is M, have a symbol table or has a symbol table that contains information about the symbols. That is each relocatable object module, every module, for example M, has a symbol table, contains the symbol table that contains the information about the symbols that are defined and referenced by the M. Suppose I have a module or I have a relocatable object that is A.O. Right. So that A.O as a symbol table that contains the various information about the symbols that are defined by the A.O and that are referenced by the A.O. In the context of linker, there are three kinds of symbols. So in terms of linking, there are three kinds of, or there are three types of symbol that is available. One is global symbol, next one global symbol, next one load symbol. So there are three types of symbols. One is global symbol that are defined by the module M and that can be referenced by other module. So this is the global symbol that are defined by module M and that can be referenced by other modules. Global linker symbol correspond to non-static C functions and global variable that are defined without the C static attribute. So these global symbol are defined by the module. For example, relocatable file have a module M. So these are defined by the module M and referenced by the other module. Means can be used by the other module or referred by other module. That is known as the global symbol. That is one of the symbol that is used in the compilation, that is used in the linking part. Then next is your global symbol that are referenced by the module M. First one is that are defined by module M. Next one is global symbol that are referenced by module M but defined by some other module. So this is the vice versa global symbols. First one says that are defined by module M. Next one says that are referenced by module M, that is our main module, but defined by some other module. But in first point it is said that can be referenced or that can be available by other module or that can be referenced by the other module. Second point says that can be defined by other modules. Such symbols are known as the externals and correspond to the C functions and variable that are defined in other module. Means such functions or such symbols are known as the external ones and correspond to the C functions and the variable that are defined in other modules. So, there are till now we have covered two types of symbol. Both are of global symbol, but one is defined by the module, main module, and one is referenced by the main module. Then next one is local symbols that are defined and referenced exclusively by module M. That is a local symbol that is both defined and referenced by the module M. So global symbols are referenced by the module M and defined by the module M separately, but local symbols are defined and referenced by the module M at the single go at the same time. This point says some local linker symbol correspond to C functions and global variable that are defined with the static attribute. That is, these correspond or symbols correspond to the C function that is available for global variable and that are defined with the static attribute. These symbols are visible anywhere within the module M but cannot be referenced by other modules. That is, it are defined or it is available or it is visible at any module within the module M but cannot be referenced by the other module. This says it is important to realize that local linker symbols are not the same as local variables or local program variable. Means symbols are not the variable that is defined in the any programming language. No, that are the different one and this is a different one. So symbols and the programs variable are not same. Then next point says or next line says the symbol table in .sim tab, that is symbol table, does not contain any symbols that correspond to local non-static program variables. These are managed at the runtime on the stack and are not of interest to the linkers. So these are the symbols, three kinds of symbol that is available in the or that is available in the linking concept. This says, interestingly, local procedure variables that are defined with the C static attribute are not managed on the stack. Instead, the compiler allocates space in the .data or .bss for each definition. That is, the local variables are defined with the static attribute are not available on the stack, but it is allocated the space or it allocates the space in the BSS or the .data for the definition and creates a local linker symbol in the symbol table with a unique name. So this says it creates a unique symbol, it is defined or it allocates the space in the .data or BSS for each definition. This is, for example, suppose a pair of functions in the same module defines a static local variable that is x. This is int f. This is static int x equals to 0, that is starting with the x. Starting with the f, that is function, and there is a variable declared that is of static type, that is int of int type. X is a variable name and that contains or that is initialized to the 0. There is a return x. Then again next function is declared, that is g, static int x equals to 1, that is 1 is initialized to the x, then return the x. In this case, the compiler allocates for two integers, that is in data, and exports a pair of unique local linker symbols to the assembler. That is, it allocates two variables, two integers, that is x and the x. But one x contains 0 variable or 0 value, another x contains 1 value. That allocates the space for two integer in the data and exports a pair of unique linker or local linker symbol to the assembler. For example, it might use x.1 for the definition f and x.2 for the definition g. So this uses x.1 and this uses x.2. Next point says, symbol tables are built by the assembler using symbols exported by the this says symbol tables are built by the assembler using symbols exported by the compiler in the assembly language. For example, our .s file. An ELF symbol table is contained in the .symbol table section. It contains an array of entries. Figure 4 shows the format of each entry. Now let's see what is figure 4. This is the figure 4, that is type def struct, means a structure is declared with the type def keyword, and then these are the multiple variable that is used. One is int name, that is of string table offset, then int value, that is section offset or the VM address, then int size, that is object size in bytes, then char type 4, that is data, function, section or src file name, that contains 4 bits. Then there is a binding, that is either local binding or global binding, that contains 4 bits. Then there is a char reserved, that is an unused char. Then there is a char section. This is the structure of the, or this is the struct variable that is predefined, or that is type def is used in the this one. This says ELF symbol table, type and binding are 4 bits each. For example, here are the last 3 entries in the symbol table for main.o as displayed in the GNU read ELF tool. So these are the last 3 entries, 8, 9, 10. The first 8 entries which are not shown are the local symbol that the linker uses internally. So these are the external symbols, or these are the last 3 entries that are used or that is contained in the symbol table for main.o. But the first 7 entries or the first 8 entries is not available, is not shown. Why? Because these are of local variable, these are of local type, and these that of local symbols. Now let's see with the help of PPTs what is symbol table. This is chapter number 7 continued. This is symbol table. This says when identifiers are found, that is when constant or the identifiers are found, they will be entered into a symbol table. As I told you, when symbols are available in the program, they will be entered in a symbol table, which will hold all relevant information about the identifiers. The same concept which I told you, that is symbol table contains symbol or the contains the module which contains a symbol which contains relevant information about the module. This information will be used later by the semantic analyzer and the code generator. So symbol table contains the symbol which contains the information, relevant information about the main module. And this information will be used by the semantic analyzer and the code generator. So this is lexical analyzer, this is syntax analyzer, this is semantic analyzer, this is code generator. So this passes the data to the syntax analyzer, that syntax analyzer passes the data to the semantic analyzer, then code analyzer, and symbol table is available for each one. That is, it deals with the it is used by the syntax analyzer that contains the syntax, and it is also used by the every module, that is code generator, semantic analyzer and the lexical analyzer. Now what is the variable or what are the content that is stored in the symbol table? That is your symbol table entries. We will store the following information about the identifier. That is, the following information will be stored in the symbol table. That is the name, the data type, the block level, the scope, the offset from the base pointers. As I told you with the help of the book. This is the example. As I told you, this is the name. First of all, there is a name, there is a data type, there is a block level, that is size, then scope, either local, global, then offset parameter for local variable and parameters only. So this is symbol table entries that contains either name, either data, either block level, not either, means it contains all the things: name, data type, block level, scope, offset from the base pointer. Name as a string that contains number of or n characters that ends with the null character, that is collection of characters. Data type means either int, float, char, maybe predefined data type, maybe user defined data type, and maybe reference variable that is used in the as a data type. Then next is your block level, that it defines in which block it will be available in the program. Then scope. Scope includes the global, local or the parameter. Then offset, that is offset from the base pointer for the local variable and parameters only. So it contains, or the symbol table contains the following entries, and it contains all the information about the identifier, about the module, that is for example M. This says this information is stored in an object, that is all the information is stored in an object known as the ID entry. So all the relevant information which I discussed in the last slide, that is stored in an object known as the ID entry. This information may not all be known at once. That is, this information may not be or may not all be known as the at once or at one time, but it is available or it is used by at every time. That's why may not be known at once. We may begin by knowing only the name and the data type, but then later the block, the level, the scope and the offset. That is, this information is not, or the all the relevant information is not knowing at one time or at once, but it starts with the, or it begins with only knowing the name and the data type. Then later the block level, the scope and the offset is also added or knowing in advance for the symbol table. So this is a symbol table. In simple terms, that contains a symbol that contains the relevant information about the module. Then what is the symbol table functions? The two most basic symbol table functions are the one that inserts a new symbol and lookup an old symbol. That is, these are the two functions that is available for the symbol table. First of all, one is a symbol that is used for installing a new symbol. Then next one says, or next one function is to look up a old symbol. This is ID entry install. This is used for installing a new symbol. This is used for looking up or for look up a old symbol. That is the syntax: ID entry install string s int blk lev. Then how to insert a symbol, that is how to insert a new symbol. The install function, this is the install function, will insert a new symbol into the symbol table. Every symbol has a block level, that is block level 1 equals to keywords. That is, every symbol that is installed, this is your BLK level, that is int type, that is of int type. So it contains or it stores the block level, that is different levels of the block level 1, that is if I'm using level 1, that is used for only keywords. Level 2 is used for the global variables. Level 3 is used for the parameters and the local variables. So every symbol contains 3 block level 1, block level 2 and block level 3. Install will create an ID entry object and store in the table. So this is how to install a new entry. So install function is used for inserting a new symbol into the symbol table that contains multiple block levels, that is block level 1, block level 2 and block level 3. This is how to insert a new symbol. That's install function is used to install a new function. Then next one is when the symbol is first encountered by the lexer, we don't yet know the scope or the type. That is determined later by the parser. That is, at first go there is a requirement of the name and the data type. For example, we could first encounter the symbol count in any of the following context. That is int count. This is the first scenario. This is the first level. That is a variable. Then int func, that is a int function that contains the two variable or the two parameter, that is int sum and the float count. Then there is a int main function that contains the int count. Then looking up a symbol. So this contains two parts, two functions. One is installing. We have studied about the installing, how to install a symbol, then how to look up a symbol. This point says whenever a symbol is encountered, we must look it up in the symbol table. So whenever a symbol is available or encountered, we must look it up, or we must look it for the, or look up for the symbol table. If it is the first encounter, then ID lookup will return null. That is, if it is available, or if it is the first encounter, that is, it is encountered at first, then the ID lookup will return the null value or return the zero value. Then next point says if it is not the first encounter, that is, it is already available at the previous stage, then ID lookup will return a reference to the ID ref entry for that identifier found in the table. That is, in simple terms, when a symbol is encountered, we must, or the computer must, look up into the symbol table. And in the symbol table, if it is available at first, at previous, that is, it is first encountered, or it is previous encountered, there are two scenarios. If it is first encountered, that is at the first time, then it returns the value, or the ID lookup function returns the value as null. But if it is not the first encounter, then it will return a reference for the identifier that is found in the table. Once we have the ID entry object, we may add the information to it. So once we get the object, once we have the ID entry object, we may add the information to the ID entry levels. Since a variable should be declared when it is first, means the variable should be declared when it is first appear, that is at the first time. If the parcel is parsing a declaration, then it expects ID lookup to return the null. If the parser is not parsing a declaration, then it expects ID to return null. That is, the data is available in the symbol table. In each case, anything else is an error. That is either the null or the null value. But if I say there is a decimal form values, that is not a correct one, that is a error. That is, in any other case, everything else is an error. Next is your block levels. That is, what is the block level? As I told you, there are three kinds of block level. This is the block level. This is block level 1, that is used for keywords, then global variables, then parameters and local variables. So this is block level, that is, first global variables, keywords and local variables are stored at the different block level. That is, at first there is a keyword, second there is a global variable, third there is a local variable. C and C++ recognizing further level, that is block within the functions, that is eliminated, that is used by the braces. This is the braces that is used. However, in C, variable locals to a block must be declared at the beginning of the block. That is, the variable that is declared or that is local to the specified block. Suppose I am using, or I am declaring the variable, or I am declaring the variable for one block. So that is available to that block only. That is local to that block. That is must be declared at the beginning of the block. If I am writing the program, I am declaring the variable in the block at the top, not at the end. Why? The main reason is that in any programming language, variables are declared at the beginning, at the top of the block. Every time we enter a block, the block level increases by 1, and every time we leave a block, it decreases by 1. These are the block levels, definition of the block level. That is, first of all, it can are delimited or it are used by curly braces. Second, variable are local to the block must be declared, that is a local variable must be declared at the beginning. Every time we enter a block, it increases by 1, and every time we leave the block, it decreases by 1. This is the structure of the symbol table. This says we will implement the symbol table as a linked list of the hash tables, one hash table for each block level. That is how it will be defined, how it will be used, how symbol table will be used by implementing the hash function, by implementing the hash data. This says we will implementing the symbol table as a linked list of the hash tables, one hash table for each block level. This is level 0, level 1, level 2, level 3. Level 0 contains null value, level 1 contains the hash table of keywords, level 2 hash table of globals, level 3, hash table of local. This is block 1, block 2, block 3, and this is block 0. This is the structure. Initially, we create a null hash table at level 0. This is a level 0, that is at 0. Then we increase the block level and install the keyword in the symbol table at level 1. This is level 0, this is level 1. That is hash table of keywords. Then next is your, we increase the block level and install the global at level 2. That is level 0, level 1 and level 2. This is for globals. In the same way, we enter a function, we create a level 3 hash table and store the parameters and local variable there. So these are the 4 levels that is used. This is used for the starting phase, that is it returns a null value. These are the 3 blocks that is used, block 1, block 2 and block 3. When we leave the function, that is when we going out of the program, the hash table of local variable is deleted from the list. That is level 3 is deleted. Then if we enter another function, a new level 3 hash table is created. So this is if we leave the function, this is related level 3. Now if we enter another function, a new level 3 hash table is created. That is level 3 hash table of locals. When we look up an identifier in a symbol table, we begin the search at the head of the list. Means if I want to search or if I want to search anything in the symbol table, then first of all go to the block 3, then block 2, then block 1. That is start searching from the top, that is from the starting, that is at the highest level, that is level 3. This is level 3. This is the hash table of locals, then hash table of globals, then hash table of keywords. If it is not found there, then search continue at the lowest level. Then search goes to the next level, that is a lowest level, that is level 2. Means after level 3, it is going to level 2, then it is going to level 1, then it is not available, then it is not available in the level 1 also. Next, looking up a symbol. If an identifier is declared both globally and locally, that is if identifier is declared either at this level, locally or globally, or both the local and the global, which one will be found when it is looked up? That is, if it is available at the block 3 and the block 2, then which function or which identifier will be found or will be looked up? If an identifier is declared only globally and we are in a function, how we will it found? How do we prevent the use of keyword as a variable name? So these are the 3 questions that is used for the looking up a symbol. That is, either we use both globally and the locally, either we use only global variable, either we use the keyword or the as a variable name. Now let's see with the help of book. This is what we have covered. These are the symbol tables are built by the assembler using symbols exported by the compiler into the assembly language .s file. ELF symbol table is contained in symbol tab section. This is what we have covered. This is the example. Till now we have covered what is symbol, how we can identify a symbol and how we can look up the symbol. Next topic is your symbol resolution. Now what is symbol resolution? This is the file. This is symbol resolution, weak symbols, how compiler resolve multiple symbol. First of all, what is symbol resolution? Linker need to find the definition of all the global variable before generating an exe or .out file. That is, before converting into executable file or the relocatable file, linker need to find the definition of all the global variables before generating an executable file. This process of finding and association each global symbol with the definition is known as the symbol resolution. In simple terms, when we find and when we compare the global symbol with the definition in the symbol table, that is, if I have a symbol, I can search in the symbol table. I can find the symbol in the symbol table. I can associate the global symbol with the definition. That is known as the symbol resolution. In simple terms, when we map the symbol into the symbol table, that is known as the symbol resolution. So whenever there is a requirement for mapping the symbol into the symbol table, that is known as, or that is done by the person, and that process is known as the symbol resolution. This says linker need to know the or find the definition of all the global before generating an exe. This process of finding an association each global symbol with the definition is known as the symbol resolution. Again, talking in loose terms, avoiding shared libraries. For local symbols, resolution is straightforward. The local symbol must be defined in the same module, but it is not in my hand, or it is not required to find the or to find and associate the symbol if it is a local symbol. So the finding and association of the symbol is done only in case of the global symbol, but if it is a local symbol, resolution is straightforward. Local symbol must be defined in the same module only. For static, local, global variable are of kind of easy. Compiler wants them to define in the same compilation unit, that is .a file. However, resolving reference for global variable is tricky. Whenever we use the symbol resolution in the global variable, that is so tricky. When compiler encounters a global undefined symbol, it makes an entry to the linker table. That is, whenever a compiler finds or encounter a global undefined symbol or a global symbol, that is, it makes an entry to the linker table. Assumption is that it must be defined in one of the other modules. So this simple says symbol resolution is used for the mapping between the symbols and the symbol table. Now let's see. The linker resolves symbol references by associating each reference with exactly one symbol definition. That is, it resolves, or the linker resolves symbol references by associating or by initializing, by identifying or by gaming each reference of the symbol with exactly one symbol definition from the symbol table of its input relocatable object file. That is, for mapping, for resolving symbols with the symbol table, we use the concept that is known as the symbol resolution. Symbol resolution is straightforward for the references to the local variable, as I told you. That is straightforward for the local variable that are defined in the same module, but these are not same as the global variable. These are reference to the global variable. The compiler allows only one definition of each local symbol per module. That is, if there is a local symbol that defines only one local symbol per module, the compiler also ensures that static local variable which get local linker symbols have unique names. Next point says resolving references to global symbols. That is, if there is a resolving reference to the global symbol, have Hello, hello, hello. Hello, 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 hello. Now, are you able to hear me, Nelda? All right. So symbol resolution, if there is a global symbol, so that is so tricky. When the compiler encounters a symbol, that is if a compiler generates a symbol that is not defined in the current module, it assumes, that is the compiler assumes that it is available in some other modules, generates a symbol or generates a linker symbol table entry and leaves for the linker to the handle. Now, if the linker is unable to find a definition for the reference symbol in any of the input module, it prints it prints an encryption message, error message, and terminates the symbol. This is void foo, void. This is a function that is used, that is a symbol. There is a int main, then foo function is declared, and then there is a return 0. And this is the how we are generated or how we are using the in a Unix system. This says symbol resolution for global symbol is also tricky because the same symbol might be defined by multiple object file. That is, more than one symbol might be defined or used by the same object file. That's why it is very tricky for using the symbol resolution for the global symbols. The approach is adopted by the Unix system involves cooperation between the compiler, assembler, and linker, and can introduce some buffering bugs to the unwary programmers. Now, how linkers resolve multiply define global symbol. That is, now how compilers do these tasks. This is the next concept, that is the difference between or the distinction between the keywords and the identifiers. This is the difference. Now, what is the difference between the keywords and the identifiers? The keywords are installed at level 1 before the lecture begins. When the lecture finds an identifier, it looks it up in the symbol table. That is, the keywords are installed at the level 1 before the lecture begins. Then when the lecture finds an identifier, it looks it up in the symbol table. If it finds at level 1, it returns the appropriate token or the appropriate keyword token. Otherwise, it returns an identifier token. So if it finds at level 1, it returns the appropriate keyword token. Otherwise, it returns an identifier token. So what is the difference? Keywords are the terms or the words that is very specific, that is available at every point, that is at keyword, and identifiers are the variable or the points or the words that is used for the symbol tables. Then the benefits of this is that it greatly simplifies the lecture. For example, imagine that a program has identifiers EL, ELS and LEL, SES. The regular expressions for true identifiers will be immensely complicated, as you know. However, in JLX, we could list the regular expressions of the keyword first, then the regular expression for the identifier. So this is the difference between the identifier and the keywords. Next is your hash table. That is a different concept. So let's take five minutes break only, because there is a huge delay due to some gap due to the network issues. But only take 5 to 10 minutes break, then come back starting the next topic. Starting with this topic, how linkers resolve the multiply define global symbol. So only take 5 to 7 minutes break. Okay.